Hi everyone, I'm Udeme Ekpo, chemistry teacher with DoLessons.com. In today's chemistry lesson, we'll be looking at chemical combination. Chemical combination is a process in which two or more elements come together by sharing electrons or exchange of electrons to form molecules or compounds. Why they undergo this combination so that they can attain the duplet or octet configuration, like the noble gases in group 8 of the periodic table. So all other elements strive to be like the noble gases by accepting electron or giving out electron or sharing electron pairs between themselves in order to attain this duplet configuration or octet configuration. In duplet configuration, the elements involved will have a maximum of 2 electrons in the outermost shell, while for the octet configuration, the elements will have 8 electrons in the outermost shell. In today's chemical combination, we're looking at 2 main types of chemical combination. The first type is the electrovalent or ionic combination, and the second type is the covalent combination. The covalent combinations are of 2 types: the ordinary covalent combination or the coordinate covalent combination. In electrovalent combination or ionic combination, the combination is usually between a metal and a non-metal. Reasons is that in electrovalent combination, one of the participating elements will have to give out electron to the other combining element. For example, if element A is combining with element B, one of them will have to give out electron to the other element so they can get to form AB. Let me show an example of electrovalent combination. A combination between sodium and chlorine is an electrovalent combination. Sodium is a metal while chlorine is a non-metal. Sodium has 11 electrons. The 11 electrons will be arranged in this form. The first 2 electrons are in the innermost shell of sodium. The remaining 8 electrons, the second shell, that's the first shell is the K shell, the next one is the L shell, while finally the M shell will have 1 electron, and that will complete the 11 electrons of sodium. While chlorine has 17 electrons, 2 in the innermost shell, 8 in the next shell, while the last shell has 7 electrons. So sodium has 1 electron while in the outermost shell, while chlorine has 7 electrons in the outermost shell. Sodium, in order to attain an octet configuration, will have to give out this 1 electron, because giving out 1 electron requires lesser energy than accepting 7 more electrons to have 8 electrons in the outermost shell. So this is sodium with 8 electrons. I need to draw 1 electron in the outermost shell, while chlorine will have 2 in the innermost shell. Now, I'll shade the electrons. The electrons in chlorine are shaded, so we can differentiate after the transfer of electrons. You can cut out all this. Now, in this combination, sodium will transfer this 1 electron to chlorine. So at the end of the reaction, you have 2 shells with 1 of the electrons from the sodium atom now in the chlorine atom. So you have the sodium will now be sodium ion, that's sodium that has given out 1 electron, and you have 2 electrons in the innermost shell and 8 in the next shell, while the chlorine will be chloride ion with 2 electrons in the innermost shell, 8 in the next shell. Then the final shell will have 8 electrons. So in this process, both of them have attained the octet configuration with a maximum of 8 electrons in the outermost shell. Now, the ionic bond or electrovalent bond is now this attraction between sodium, which is now positively charged, and chloride ion, which is negatively charged. We all know that positive charges attract negative charges. So when sodium gives out electron, it becomes positively charged. Chlorine accepts electron and becomes negatively charged. So the attraction between the positive and the negative charges is what we call electrovalent bond or ionic bond. And other examples involve a bond between calcium and chlorine, in which calcium will have to give out 2 electrons to chloride ion. In that case, we have calcium has 20 electrons, the 4 shells, while chlorine has 2, 8, and 7. Now, since we have 2 electrons on calcium that needs to be transferred to chlorine atoms, so we need 2 of the chlorine atoms to accept the electrons, so that at the end of the reaction, you have calcium chloride, with the calcium giving out 2 electrons to be 2, 8, 8, while the chlorine having accepted, that is 2 chlorine atoms, having accepted 2 electrons will be 2, 8, and 8, both of them with octet configuration. So that's that for the electrovalent compounds, electrovalent combination. Now, compounds that are formed from this type of combination usually have high melting and boiling points. They are usually solid at room temperature, and they form what we call electrolytes, because as a compound, when they dissolve in water, they form freely moving ions, because they are formed from giving out an acceptance of electrons. So they are useful electrolytes used for the process of electrolysis. They only conduct electricity when they are in solution or in molten form, but as solids, they will not conduct electricity because the ions are held together by the strong electrovalent force of attraction, so they cannot conduct electricity in solid form. The second form of combination, the covalent combination, involves sharing of electrons between the combining elements, usually between 2 or more non-metals. For the ordinary covalent combination, the electrons for the combination is contributed evenly between the 2 participating atoms. For example, for ordinary covalent combination, we have a type that involves formation of single covalent bond. Example, in the case of hydrogen, if hydrogen atom combines with another hydrogen, it forms hydrogen gas. Hydrogen atom has just 1 electron. When it combines with another one that has just 1 electron, they will come together to share equal number of electrons contributed by the 2 participating atoms. So you have this is the hydrogen gas. So this type of bond is single covalent bond. Now, in oxygen, we have double covalent bond between two oxygen atoms. Oxygen has 8 electrons, and 2 of the electrons are in the innermost shell, while the remaining 6 are in the outermost shell. So when it combines with the next oxygen, we have this. Two of them will get to share 2 electrons each because they are in need of 2 electrons. Now, if you look at this, oxygen has 6 electrons already. To attain the octet configuration, it needs 2 extra electrons. So for it to get the 2 electrons, it has to share 2 electrons because this is a covalent combination. So we are going to have something, 2 electrons here. 1, 2, 3, 4, 5, 6. Now, the 2 oxygen atoms come together and they share equal number of electrons. What I just want to point out here is that the electrons in ordinary covalent bond, the shared electron pairs are contributed equally by the 2 combining atoms. This pair of electrons that is shared between them is called shared pair, while the one that is not involved in the bonding is called the lone pair of electrons. In nitrogen, nitrogen atoms form triple covalent bond in which they get to share 3 electrons each, contributed equally by the 2 combining nitrogen atoms. We also have covalent combination in hydrogen chloride, carbon 4 oxide, carbon 2 oxide, and other compounds that are made up of majorly non-metals. Now, for coordinate covalent combination, the electron shared pair, that is the shared pair of electron, is contributed by only one of the combining atoms. It's not like the case of ordinary covalent bond in which each of the combining atoms will contribute equal number of electrons. In this case, only one of the combining atoms provides the electron that is going to be shared. For example, if A is combining with B in a covalent combination, A will supply all the electrons needed for the combination, but both of them will get to share the electrons. All the electrons needed for the sharing is contributed by one. Example, in the formation of ammonium ion, hydrogen ion from an acid combines with ammonia gas to form ammonium ion. We all know that hydrogen as an atom usually have 1 electron. So if you are talking about hydrogen ion, it means the shell is virtually empty. Now for ammonia gas, in ammonia gas you have nitrogen linked to 3 hydrogen atoms. Now, nitrogen originally has 5 electrons in the outermost shell. It needs 3 more electrons to have an octet structure. So it has to share 3 of the 5 electrons to form 3 covalent bonds. The 2 remaining electrons is what we call the lone pair. So ammonia is going to supply this lone pair of electrons to the hydrogen ion to form what we call a coordinate covalent bond. The 2 electrons will be brought and hydrogen ion will get to share the 2 lone pair of electrons. That's how ammonium ion is formed. In this case, we are going to have something like this. 2 hydrogen. Then finally, this hydrogen ion will come here and we'll have, this is now NH4 plus, this was NH3. N is the one here and we have 3 hydrogen, and this is hydrogen ion. So at the end of the combination, you have 2 electrons contributed by only ammonia shared between hydrogen ion, and ammonia gas. In the next lesson, we'll look at other combining forces like hydrogen bond, van der Waals forces, and weak intermolecular forces of attraction between molecules. I hope you enjoyed the lesson. Thank you.